Hello, my name is Jerome Mutabazi. I'm a teacher of physics and mathematics at GS Remera Catholic. I come with the science laboratories, but mainly those which are online laboratories. But today we are going to see some online laboratories that we can use while we are teaching as a teachers some science subjects like the concept in physics, concept in biology, and concept in chemistry. Or instead, you can use some online laboratories. We don't have the well-equipped physical laboratories. So I ought to use the PhET simulations. PhET means Physics Education Technology. It has been developed by the University of Colorado and donated to some African countries use it as to make the science more easy and understandable. So you can use your own smartphone, computer, just to access those simulations, and you can do it more easily. So you go on PhET, you go on Google and search PhET. PhET means Physics Education Technology. You get PhET simulations. Then you click. You click. We do have many simulations in physics. Including buoyancy, generators, magnetic and electromagnets. We shall see later. But today we are going to see forces. Let's make some simulations on forces. Forces, non-forces, and motion also. Because as you know, force and motion, they are two sides of the same coin. You cannot have motion without force. Yeah, force and motion. Because the force causes motion. Not a motion must have a force. So that's why this simulation combines force and motion at the same time. So you click on force and motion basics, then you enter and make sure that you have enough connection. Make sure that you have enough connection. Let us start for the net force. Here we do have some features on this simulation. We do have the box which is at the top right corner, which has sum of force. You have to pick, so it will display the resultant force or the sum of the forces. I do have another box values that will show us the magnitude of the forces, and the box of speed will show us the speed of this moving object. Now, on the bottom, we do have the two boxes, one on the right, another on the left. The one with the lady colored people, another with the blue colored people. We can pick one for the red card people and another for the blue card people, and with their magnitude will be displayed. So this one, if I put this one, so it shows this red people has 150 newtons, which is going to act lightward. You remember that the lightward force, they are always positive. And you can take another one here, the blue one, but very small, with 15 newtons. And you can just imagine, you can just be amazed how it will happen if one pull another one pull in those respective directions. And we have to check the one who will win. You can guess the one who will win, but according to the magnitude of force, you can see the sum of the forces will be 100 newtons, which is acting on the lightward direction. Just this means that red has to win. Let us see. Uh, wow, red wins. Now let us go back. What if we put another blue one here? Uh, the resultant force is equal to 50 newtons. The blue has 200 newtons acting leftward, and the red has 150 newtons acting rightward. So the sum of the forces will be 50 newtons acting leftward. You remember that though this direct leftward, that's negative. It will move in a negative direction or toward the left. So you can see when if the resistant force is acting leftward, this is why how the motion of this object will be oriented in that direction. You can see. Let us go. Wow. So obviously the blue wins. Yeah. Okay. Let us come back. What if I put another red here on rightward in rightward? If I put another red, so the sum of the force is equal to equal to 0. So what means the forces are balanced, they are equal. 200 newtons, 200 newtons. Here we go. Now they balance. So that is it for the forces of the unbalanced force. When you add them, so the direction of the force, direction of the motion will be oriented on the greater one, on the greatest force. That's where we have the direction of the forces. Now we can go to motion. On motion, do have forces. Of course, it's not have motion, must have force. For the force is the cause of the motion. So we must have the values, including the masses, the object, speed. That is and it's very just unnecessary. According to the second law of Newton, the acceleration of moving body is directly proportional to the applied force and inversely proportional to its mass, and it will take the direction, the motion will take the direction of the applied force. This means if the force, the applied force increases, also the motion of moving body, the acceleration of the moving body will increase. If the mass increases, also the acceleration will decrease. So they are inversely proportional. Then we can see this man is pushing the box with the indicated force. Now can see its speed. Speed also increase. Now, what if we do increase the mass? If I put another mass here, it is now 150 newtons and apply the same force. Now you can see the speed very, 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 very slow. It moves very slow. So this means the mass increases but the acceleration decreases. Now you can see for the second law of Newton. Now, now here we do have can put also we can increase the size of the applied force. If I include the force, also the acceleration will increase. Okay, if the size of the force, yeah, that is all about the motion. What about the concept of the friction force? Now, can you put the friction force in a motion? You remember the friction force, it is the force which opposes the relative motion of a moving body. Now you can see the surface is not smooth, it's somehow loose, you can see. Then here you have can indicate the sum of the forces, values, masses, and speed. Now here, if I do apply this one, you can see the applied force is equal to 18 newtons. What 18 newtons? Friction force is equal to 18 newtons. So cannot cannot move because the forces are balanced and acting in different directions. But if I do increase, now you can see the net force will be equal to 130, then we increase so. But there is the action of the friction force toward the surface of the object. So the friction force can see reduce or just oppose the motion of the moving body. So you can minimize this friction force by using oil on the surface, just by raising or doing different technique to reduce the friction force. But oiling on the surface normally reduce the friction force. Now, what about the acceleration? Now I have seen the additional forces. I've seen the motion according to the second Newton's law, how the mass of the body affects its motion, its acceleration, how the applied force affects acceleration. Now let us go to, now we are on the friction force, how the friction force oppose the motion of a moving body. So that is it. You can, if you do increase the friction force here, can increase also the friction force. If you increase, the motion also decrease. Hmm? It moves very slowly. That's how the friction force affect the motion of the moving body. We can go to the concept of acceleration. Also, the acceleration, remember, depends on mass of a moving body and the applied force. Hmm? So if I increase the applied force, hmm, the body will move very, very, very rapidly. That still has very great acceleration. Very great acceleration. Okay. That is demonstrating this simulation. So you can also now go to this quantified simulation and go to force and the motion and practice it to make very simpler, simpler and understandable to the students. Thank you.